November 10th, 2020. Microsoft launched the Xbox Series X for $499. And the first thing people noticed wasn't the specs, it was the shape. This thing looks like a PC tower, a monolith. Some people joked it looked like a mini fridge. Microsoft actually leaned into the joke and made a real Xbox Series X mini fridge. But here's what most people missed. Microsoft didn't design this console to look cool. They designed it to solve a problem that would have destroyed any other shape. Inside this tower is a cooling system that's more sophisticated than most gaming PCs. And the shape you see? That's not marketing. That's physics. At the heart of the Series X is a custom AMD chip built on TSMC's 7-nanometer process. This is massive silicon, 360 square millimeters. For context, that's about the size of your thumbnail. The CPU uses AMD's Zen 2 architecture with 8 cores at 3.8 GHz. That's the same architecture powering high-end desktop processors. The GPU uses RDNA 2 with 52 compute units. That's 3,328 cores, delivering 12.15 teraflops. The previous Xbox One X managed 6 teraflops. This delivers double the power. But here's the problem Microsoft faced. This chip pulls 200 watts under load. That's as much power as a desktop graphics card. Most gaming PCs can handle 200-watt components because they have room for multiple fans, massive heat sinks, and open airflow. The Series X has to fit in your entertainment center, next to your TV, where you can actually hear it if it's loud. Microsoft needed desktop performance with laptop-level acoustic control. The answer is a copper vapor chamber combined with aluminum fins and a single massive 130mm fan. This isn't typical console cooling. This is desktop-grade thermal management in a compact form. The fan itself is interesting. It's surrounded by a custom plastic fairing with an in-mold Master Chief logo, a tiny Easter egg that most users will never see because it's hidden inside the console. But Microsoft put it there anyway. Here's how the vapor chamber works. Inside a sealed copper chamber, there's liquid. When the chip heats up, that liquid evaporates into gas. The gas rises and spreads across the chamber surface. When it touches cooler metal, it condenses back. This cycle transfers heat incredibly efficiently across the entire chamber. The vapor chamber sits directly on the chip with thermal paste. Heat spreads horizontally across the chamber, then transfers vertically to aluminum fins stacked above. The 130mm fan pulls air in from the bottom, passes it through those fins, and exhausts it out the top. This creates what's called a chimney effect. Hot air naturally rises, and the fan assists that flow. It's why the console is a vertical tower. The shape isn't aesthetic, it's functional. The results? The Series X runs at 47 to 50 degrees Celsius under load. That's significantly cooler than the Xbox One X, which hit 65 degrees. And it does this while drawing less power, 128 watts versus 180 watts for the One X. But the vapor chamber isn't the only clever part. Microsoft split the motherboard into 2 sections connected by a central chassis. The main board holds the AMD chip, the 16 gigabytes of GDDR6 memory and power delivery. A secondary board houses the disk drive and front I/O. Between them sits a metal chassis with precisely positioned ventilation holes. These holes aren't decorative. They're calculated for maximum airflow while blocking dust. The pattern on the outside mirrors the internal structure, creating aligned air channels from bottom to top. This split design creates a clear thermal pathway. Heat flows from chip through vapor chamber, through fins, straight out the top. No hot air gets trapped. No components cook each other. It's why the Series X can maintain consistent performance during multi-hour gaming sessions without thermal throttling. The Series X has 16 gigabytes of GDDR6 memory split into two pools. 10 gigabytes runs at 560 gigabytes per second for graphics. 6 gigabytes runs at 336 gigabytes per second for everything else. Why split it? Cost and efficiency. Games need fast memory for textures and frame buffers. CPU operations and audio don't need the same bandwidth. About 13.5 gigabytes is available for games. The OS uses only the slower pool. The Series X shipped with a 1TB custom NVMe SSD. Load times dropped dramatically compared to hard drives. Microsoft built a custom file decompression block directly into the chip. When games load compressed assets, dedicated hardware decompresses them without using CPU cycles. Faster loads, free CPU. For expansion, they created a proprietary 1TB card that slides into the back. Expensive at $220, but maintains internal drive performance. Regular USB drives work too, but can't run Series X optimized games. Those need the speed. The Series X launched right as a global chip shortage hit. TSMC's 7nm process was in high demand. Everyone from Apple to Nvidia needed it. Microsoft couldn't produce enough consoles. Units sold out instantly. Scalpers bought them for $500 and resold them for over $1,000. Microsoft had started manufacturing late because they were waiting for AMD's chip technology. They reached full production by launch but still couldn't meet demand through most of 2021. The irony? The chip that made the console powerful was also the chip that made it impossible to buy. So was the tower design the right call? Absolutely. The vertical orientation enables the chimney effect. The 130mm fan provides airflow without noise. The vapor chamber spreads heat across a larger surface. The split motherboard creates clean thermal pathways. Microsoft could have designed a flatter console, but that would have meant compromising on cooling, which means compromising on performance or noise. The tower shape solved the thermal challenge that the 200-watt chip created. Sometimes the best engineering doesn't look conventional. It looks like whatever solves the problem, and Microsoft's problem was keeping a desktop-class processor cool in a console package. The tower solved it. That's why it looks the way it does.